The first event, if we go back to the slide and talk about the process, at the beginning of this process, there's a trigger. Something happens that causes this process to start. What do you think could be that trigger? Why would you begin to enter into this process? Any suggestions?
Looking at the chart, I would suggest there's a request for forensics activity or analysis.
That could be one. But imagine you're a system administrator. And a system administrator is a person who could do this activity. You can mine data, you can image data. I could have done this in my role as an administrator in past lives. So when would I have started to do this process as a system administrator? Robin?
You think that you notice something suspicious and you think maybe something has happened and you want to understand it better for that system.
So I think there's an event. Something has caught my attention. Now, if you're doing an analysis as part of a law enforcement organization, it may be the case that there is a forensic request. It may be that somebody else has noticed something and has brought in law enforcement who's going to go out and image, who's going to bring it back and analyze it, who's going to figure out what's there, write a report, and perhaps testify. So those are what the triggers are when this whole process begins. So the first step in this process is you're actually going to go out and you're going to image stuff, whatever that stuff turns out to be, and we'll talk more about what that kinds of things, how they can appear as you find them in a site. To do that, you need the authority to do that. You simply can't go out and say, I'm going to go image this. I'm sure you've seen the CSI and the NCIS's genre of shows. Usually there's some type of a search warrant that kicks off the ability to go out and actually do something. So that means search warrants, whatever policies, any kind of government law, like the Electronic Communications Privacy Act or the Wiretap Act or the Pen, Trap, and Trace. So you have to be allowed to do imaging before you even begin to plan to do imaging. And the keywords at the bottom, phishing may not be allowed, and that's phishing as in, we don't know what's out there, we just want to get your computer and start looking. That is typically not allowed, at least in this country. You really have to be very specific in a warrant. Yes?
So how does that apply to an organization in the devices that they own, if they want to image those?
My understanding is that those rules are different because it's a private corporation. And so you may be actually able to do more things simply by virtue of the fact that it's part of the company. Then something like phishing activity may be allowed because the company owns the asset, and you're allowed to phish through your own computer. So it would seem reasonable to conclude that phishing may be allowed in that kind of a setting. But if you're police, if you're LEO, a law enforcement organization, phishing then becomes not an option. You have a very specific warrant looking for very specific things in very specific places, which can be a real challenge, as we'll talk about, where some of the places where good stuff could appear. Good question. So the first task is, once this process has begun, now you have authority, now you're actually going to go out and do some amount of imaging. Well, imaging means taking a bit-by-bit copy of something, taking an image, and taking that image back to do some investigation. If you're taking an image, you got to put it somewhere. Typically, that's a disk. So you need disks. Those disks need to be, again, you've seen the CSI shows, you've seen them clean all their equipment between cases for cross-contamination issues. There's nothing new here, it's just computer stuff. So the same issues. I need wiped disks so that I don't have cross-contamination from any other source. I need to be able to connect those disks onto the systems I'm looking at, so I need an array of connectors, power supplies. I need to be able to test the images that I have acquired on site. I need power cords, I need networking cables, I may need internet access, unfettered internet access so that I can go do some investigation. And again, going back to key point number one, I need some note-taking paraphernalia. I need to write down everything I'm doing, where I'm doing it, et cetera, et cetera. So I need to prepare a whole bunch of these things in advance. You may have seen these black Pelican cases that are heavy plastic, that are on wheels with handles that you could carry them through an airport, for example. We have a collection of those on our team for when we actually go on site. Spend a lot of time in advance getting all of these things ready. There's an awful lot of preparation. You're simply not going to go out today and say, oh, I'm going to buy a bunch of disks, although you might be able to from local merchants, but usually write blockers and other ancillary connectors. I may need to get USB, this paraphernalia, or SATA drives, or all sorts of other things. There's an awful lot of planning and an awful lot of inventory that you build up in advance of doing this activity. Then as you get closer, you may do some wiping, you may put things in cases, you may inventory. The key point of this is to minimize the time that you're at the site that you're imaging. And we'll talk more about that shortly. So now imagine then that you're on site and you want to capture something based on what you're allowed to capture, based on what you've been through the warrant, what you've been given authorization to capture. So the challenge is then, or the goal is to image what could be written by the suspect during the period of importance. Now, the period of importance is a nebulous term because if you're working with law enforcement, it may be a crime that was committed 6 months ago. So you want to be able to capture the materials that could have been changed by the suspect or suspects 6 months ago. Do you know what computer systems you could have touched 6 months ago? It's probably hard to define even for ourselves. So one of the situations we ran into was where we were actually going to a suspect's workplace. It was a network of Windows-based computers. The suspect had been there for a few years. File servers had come and gone. There was material in a computer room that was turned off that may or may not have been writable by the suspect 6 months ago. Permissions change, access change. You change teams, your permissions changed in file server. So it's very challenging to figure out, even in a static environment, what was possible. There's the obvious media, obvious places to look for. Disk, USB drives, CDs, and DVDs, the normal computer-related things that we're used to looking at. But these days, there's even more. For example, in my house, we have 3 DVRs. Those DVRs are Linux boxes. They have disks. They have a 160 gigabyte disk inside of them. They have USB ports. They have FireWire ports. They have Ethernet ports. Could I write something in there such that law enforcement wouldn't even bother to look? Of course, the answer is yes. Printers, you've heard about printers with a great deal of memory. I may be able to store something in there and it would never be imaged. Disguise devices. I went to a conference where there was a lady who got up and talked about all sorts of women's apparel that are USB connected. Hair clips, jewelry, underclothing, things where people would not normally look. All of these things are USB connectable devices, can be USB connectable devices, and you can use them to exfiltrate data. Unrelated devices, videos, cell phones, etc. How many of you in your house have a collection of DVDs sitting somewhere by your television? Anybody have a DVD or a CD writer where you can create a label? So I can hide information on something that looks to be a DVD, but it's really a data DVD that's got 4.7 gigabytes of information. It's there in plain sight. You chose not to look at it as law enforcement. You never imaged it. That has the good stuff on it. You missed it. I got away with it. Now let's talk about this cloud thing. Does anybody use the Dropbox application or something comparable to that? Dropbox is an application where you store files somewhere out there. And I have it on my Mac at home, my Mac in the office, my iPad, and my Droid phone. And I use it to share pictures of my granddaughter, for example. I put it in one place, they show up in other places. Where are those bits stored? They're stored out there somewhere, but they could contain information that's germane to the case. In addition, I have a file of commonly used information, which is another file in my Dropbox, but it's a TrueCrypt container. It's encrypted. And so I do essentially a loopback mount of that to gain access to it when I need it. And I can store that information everywhere. So the things that you're looking at to image are, again, what could be written by the suspect during the period of importance. That's a hard job. I envision at some point in time shrink wrapping a house lifting it off its frame and wheeling it to the police station because I didn't want to miss anything. So I just took everything. It's becoming more difficult to deal with. You want to image efficiently, which means you want only what you need to analyze, because the idea is you're going to image stuff, you're going to take it back and read into some computer system, and you're going to look through it. And if you have terabytes and terabytes of information, it's going to take a while for you to look through it, catalog it, etc. And so you want only what you need to do your job, if you can figure out what that is. So how much disk space exists in the entire organization? How long would it take to image everything? And can you be more selective so that you image only what you need or only what you think is you need? Key point here is you may not get a chance to go back a second time. Again, the CSI and NCIS shows are somewhat realistic in that they usually go to a crime scene, extract everything they need, and then go. Especially with computer stuff, where as soon as you go capture some information, then people are onto you, then they start the secure deletes, and the information is not even accessible, even if you could go back a second time. So you need to be efficient, be there only as long as you need to be there, but capture everything that you need. So that's what you're trying to do. Once you're on site, you need to make a plan, which means somebody sits down, you've done a triage step, which is identifying where all the good stuff, where you think all the good stuff is. Then you figure out the order you're going to deal with it and the specific dependencies, like this is a USB 1 connection. It's going to take 3 days to image this 200 megabytes because it is so slow. We're going to image this one over the network. So you need to mix and match all of that and then get people doing all of these images. So you need to take into account speed of the network, speed of devices, the hosts, maybe they're old IBM personal computers of 20-year-old vintage, but it's got good stuff on it. How do you get that stuff off? One of the situations we were involved in is that we were doing some imaging at an ISP. The ISP served multiple customers, of which the suspects were one. We wanted to image it in such a way that the ISP could continue to provide service to everybody else while we imaged the stuff, which means we tried not to take machines down. That was our first cut. That didn't work. We would have been retired by the time the imaging process finished. So we went to a second approach, was we turned things down, started pulling disks and using hardware imagers. You need to figure out all these things and make that plan. So at the end of a period of time, you have a plan as to what you're going to image, how you're going to image it, and then you assign your staff to go off and do that. You want to get an idea of an approximate size and then some notion of checksums, because now we will begin to get in this notion of chain of custody. We imaged it. It is a good image. It matches the source matches the target. You can then verify that in a court of law. We'll talk more about chain of custody issues. Now you're going to go off and do that. You've got your plan. Now you send out all the worker bees to go off and do that. The best way to image is when that image is at rest, which means it's not currently being used. And therefore the data won't be changing during the time that you image that. The best way to do that is to actually remove the media from a computer and use a device designed to do that image. That's the best. It may not always be possible. When was the last time you took a computer apart? Was it easy to get the device out? Or was it hard? That can be challenging. When you are reading a device, you're using a physical piece of hardware that's called a write blocker, which means that device cannot change because you've got electronics that prohibit write operations. These are small pieces of hardware to guarantee that you can't change them. What you want to do when you image is you want to image bit-for-bit copy. You don't want to use any kind of a program that would attempt to interpret the file system, like tar if you know Unix, or a copy operation if you're a Windows user. You want to use some of the tools that are fast and effective if you're doing it connecting it on the computer and using standard programs. A couple examples, DC3DD and DCFLDD. These are programs that are extensions to the standard Unix DD, where DD stands for disk to disk. Copy file to the out, in and out, no changes, as fast as you can go. We have been in a position on one of the cases we were dealing with where we had a multiple gigabyte, hundreds of gigabyte disk that was basically empty. And we made a call at the line of scrimmage where we said, we're just going to tar the information off. It was an SQL database. Rather than take the time to image hundreds of gigabytes, we chose to take a very small amount of that. How about media with errors? When you get into when you're reading media, you may encounter errors, which means when you try to compute a checksum, it's never the same twice. So you may run into some issues of admissibility with respect to that kind of media. Then you go off and actually do the imaging. Once you've identified, et cetera, you need the stuff to write it to. You need hardware and software. And again, all of these things you've taken with you in advance so that you can be there, do your thing, and go away. Hardware and software to verify the images. You need to be able to transport those images back, have chain of custody, have documentation with respect to whose hands have touched your images, have touched the removed disks from the time they started all the way through the cycle, and your note-taking material, and potentially a lot of time. I have been on these cases where you set up a bunch of images and you get coffee and you drink coffee and you get more coffee. There's nothing to do in the meantime. Everything that can be imaged in parallel is being imaged in parallel, and it simply takes as long as it takes. And that can be an awful lot of time. Any questions about these kinds of things?
I have two questions. What about capturing volatile data from memory? And then with data that's been put out in the cloud, would the warrant cover that? Or how would the warrant cover that? Volatile
data means memory and other things. And the answer is you always want to capture whatever you can capture, especially in the face of encryption. I think that's basically no, it's not the next slide. It's one of the slides shortly down. Encrypted file systems is another issue of volatile data. The question is memory, transient stuff that may be changing. Do you capture that? The answer is you capture everything you can if you can afford to. A warrant. The second question about a warrant and information in the cloud. You can get a warrant if you can convince a judge to include that in the warrant. Then the answer is you can get it if you can figure out where it is. That becomes the challenge. So the answer is yes to try.
Thank you.
Don't you ever prioritize and say, hey, this is really too much stuff to capture all of?
You need to at least figure out of everything that's capturable. Then you figure out an order, and then you go after the most important things first. With the idea being, and I have been in a case, one case where this happened, where the U.S. attorney said, you have been there long enough. You need to leave within the next hour. And so, yes, the priority of things you capture is very important, because you may all of a sudden have the rug pulled out from under you at 2 o'clock in the morning when you've been doing this for 6 or 7 hours, and you haven't captured enough, or you haven't hit the top 5 on your hit parade. So yes, the order is very important as to what you capture. Other questions? So once you've captured this, you need to verify what it is that you've captured. Typically that's handled by checksums, MD5 and SHA-1. Anymore, we do both of them. There's been some issue about MD5s being able to be crafted. So an MD5 and a SHA-1 or some other checksum, the fact that both of those may have been cracked or able to be fabricated is less likely. Again, record all this information in a journal, print things out, screenshots, what have you, signed, dated, located as to where you did it. And a problem, as I mentioned earlier, is the whole notion of data, of media that has errors. If you read a disk and it's got some bad sectors, and every time you read it, it's got a different value, you can't compute a checksum. So maybe you have to compute a checksum of those parts before the error, those parts after the error, and this was a part that we're not sure about because it has errors. So those kinds of things you need to do on site while you're there, while you got a crack at the original evidence the first time. because the chances of going back may be impossible, and even if you can, the world may have changed. And the whole point of this is there's a lot of things to think of and a lot of preparation to do. The analogy that I've often used is painting a room. Anybody ever paint a room? Tell me the steps in painting the room. Where is painting? We call it painting, but one of the last things you do is actually put paint on the wall. There's preparation, there's moving out the furniture, there's spackling, there's washing walls, there's picking out the color, there's all this other stuff. Oh, and then you put some paint on the wall, and then you put everything back. It's called imaging, but almost the last thing you do is image. There's a whole bunch of stuff you do in advance of that. And all of these can have an impact. Again, going back to the CSI genre of shows, I think it is realistic that court cases have been thrown out because of they haven't conducted their analysis properly. There was contamination, something happened in the lab, and the whole evidence was thrown out. Gee, we didn't wipe the disks because we didn't have enough time. And oh, by the way, they had information from a previous case. That's polluted this case, and all the last 2 weeks' worth of effort that you just went through, all of it's thrown out. The case is gone, and the AUSA, the assistant U.S. attorney, and you don't get along as well today as you did the day before. So a lot of this is planning and preparation.